Okay, so hello everyone. My name is Oomang Bishnoi, and I'm the senior course developer for mechatronics working with the ETG. Okay, so I'll give you a brief introduction as to what ETG and what ETG is standing for. So Elite Techno Group is a startup, and this startup is working for students to make them industrial ready. Okay, so students nowadays they lack as to what is being happening in the industry and how they need to conquer themselves as to how they can be introduced to the industry and can implement the learnings as to what they learned in college and they can implement this on the industry, right? So I'm really happy to announce our association for this boot camp with the ISL College of Engineering of second and third, fourth mechanical and electrical students. And let's get on with our topic. So today our topic is how a real robot works. Okay. So let's see what we are going to study in these slides. We are going to tell you about the history of the robotics as to where the history, how it all started and how the revolution of robotics came into being. And then we are going to introduce you to robotics as to what robotics is and what are the types of it. And then we are going to tell you what are the 3 laws of robotics that are really famous and the robotics has to work upon them. Then we are going to tell you the components, as I told you, and the types of the robots. Then we are going to do a humanoid robot case study. Okay, so let's get on with our first topic. So it all started in 1922 with the Chess author Kirill Kapik, who wrote a story called The Rosen's Universal Robots and introduced the word robota, meaning the worker, a person who can work for us, and it can like as we saw, as we also in the movie Three Idiots, that how a machine works. Okay, so a robot is also a machine. It can reduce a human effort, and that is how we can assume this robota word as worker. So in 1954, George developed the first programmable robot, as you can see right here. Okay, so this was the first robot, and particular
Mr.
type of.
Omanga, your slides are not moving and make it a big screen. Your slides are not moving.
Okay, so we'll just check.
Yeah, now it is moving.
Just hold on.
You can make it a big screen here.
Yeah, sure. Okay, is it visible now?
Yeah, visible.
Yes.
Thank you.
Okay. So this particular type of robot we are going to study in the next slide as to what, how we can define the different robots on the basis of their configuration. Okay, so in 1962, Unimation was formed and first industrial robots appeared. So this particular type of robot used to do MIG welding, and this was the implementation of the robots in the industrial field. Okay. In 1973, Cincinnati, Milacron introduced the T3 model robot, which became very popular in the industry. Okay, so this particular type of robot is the articulated robot, which has and this is called a manipulator. So what we do is this type of robot we can this is the place where we connect the end effector. So we'll tell you about the end effector later, but let me introduce you to the concept. So end effector is something that we connect to the end of this robotic arm, and then it can be used to do some different applications. Okay, so we can perform some welding, we can perform some pick and place task, we can perform painting function, and we can perform various things. Okay, some of these applications includes even making of the coffee, and if you guys have watched Iron Man, there was a robot in that movie, and that robot was of the same configuration, and that robot was used to do some work for the person that was asking him. Okay, So in the 1990s, Cincinnati Millacron was acquired by the ABB, which is now the company who is a pioneer in the development of robotics. Okay. So let's see what robotic actually is. Robot actually is. Okay. So in the robotics industry or association defines a robot as a reprogrammable, multifunctional manipulator designed to move material parts, tools, or specialized devices through variable programmed motion for a variety of tasks. Okay, so Robotics Industry Association is based in America, and this can so what this defines is that this robot, let's take for example this robot, this can be reprogrammed. Okay, so there's a teach pendant along with it, and the teach pendant is like a remote controller for the robot. That teach pendant is used to program the robot accordingly, and we can use it for different functions. So this robot is being used for welding, and then we have various tasks as to what how things can be performed, and like pick and place thing and these. Okay, so do we have any questions so far?
Yeah, please continue.
Okay. So there are 5 human system with corollary in robotics. So corollary is the correlation of robotics with the human system. Okay. So the first is the skeletal structure. So let's say this is a robot. This is the base of a robot. Okay. And then this is the manipulator. Uh, right. This one, this, and this. So these are joints of the robots, and these are called as links of the robot. Okay, so these links are joined to carry out. Then this can be defined as the axis of the robot. So let's say I'm going to buy a robot. So the person will ask me as to how many axes do you need, because the more the axis, the larger is the work envelope of the robot. Okay, so work envelope is the thing that is, let's say this is the work envelope. Okay, so this particular robot can come to this this work envelope space. Okay, so let's say this is a robot arm, and this is the work envelope of the robot. So this robot can move from this to this. Okay, so this is the skeletal structure of the robot. Next is the muscle system. So muscle system can also be defined as the joints of the robot, okay, for which it helps to move the robot and for different positions. So let's say this is the arm. I'm moving this arm, okay. So let's say this is the joint and this is the link. So this is being moved by the help of this muscle, okay. So this can act as a joint, right? Then the sensory system. So we have a sensory system as to what is happening around us, and let's see someone is touching me, okay, like this, and so I can get a sense of as to where I am being touched and who is touching me. So that is the same way a robot has some few sensors, which is used to visualize the environment of the robot, okay. Then comes the power source. So robot works on the 440 volts, and this is first introduced to the transformer and then to the whole robotic system. And power source is the main thing that moves the robot and controls the robot. Okay. Then comes the brain to process. So the brain of the robot is the teaching pendant from which is programmed by a human. Let's say we can program this robot to pick this thing from here and to pick it up and to place it here. Okay, so this is so teach pendant works as the brain of the robot. So we'll cover this all in the coming slides. Okay. So let's study what are the 3 laws of robotics that robot has to work on, and they have to obey it, and otherwise if they don't follow it, it is not a robot. Okay. So the first law is a robot may not injure a human being or through inaction allow a human being to come to harm. Okay. So robot can never harm a human, as this was a contradictory statement in the movie of that Rajnikant. So in that movie, the robot was harming the human, and it cannot harm a human. So that is the one point that we are going to cover, that that the movie was fake, but we can cover that, since that was a humanoid robot, which we'll study in the later slide. So a robot must obey orders given to it by human beings, except where such orders would conflict with a higher order law. Okay, so let's say a person wants this robot. This is the articulated robot. A person wants it to go through this place, but a robot has some senses, so it cannot pass through this stage because it will say that I am being obstructed by something. So this is the higher order law that would conflict it. And then third is a robot must protect its own existence as long as such protection does not conflict with the higher order law. So a robot has to protect its existence, and it cannot harm itself, and it has to be if it has to be harmed, it has to be from a higher order law. Okay. Any questions so far? Okay.
So continue, sir.
Yes, please.
Continue, sir.
Uh,
Continue.
Okay, sure. Okay, so we are going to study the robot components as to what is used in the robots. Okay, so first is the manipulator. So when we talk about a robot is not this thing. A robot is actually for an industrial aspect, a robot is this. Like this is a robotic cell, and this a manipulator is placed like this and this. Okay, and some kind of task is being performed. Let's say a pick and place thing, and or let's say a configuration of mobile things and everything. So a manipulator is this, and a robot is actually the robotic cell, like the Foley. Okay, so this is how the movement of the robot takes place. Then the end effector. So this, in this particular thing, this is the end effector. So this is the part that generally handles the object, makes connection to other machines, or performs the required task. Okay, so we can pick and place from this particular type of end effector. Then there's welding. Then there's then there's some sensors that can be mounted on these end effectors, which are called as machine vision, and these are used to map the whole environment as to where this robot is, and then it can be integrated into AI, and to perform some various tasks, the robot can perform these tasks on its own. Okay. Then come the actuators. So these are the actuators which are mounted on different kind of in the robotic cell. So what these does is, this plate, this hole is for the inlet, and this is for the outlet. Okay, so let's say this is a hydraulic actuator. So let's say we want to clamp an object. So what this actuator does is, this actuator, when actuated, it comes on the object like this, and it holds its part in the same place, so that some few operations can be done on it by a manipulator. Okay. So some common types of actuators are servo motors, stepper motor, pneumatic cylinders. So this is pneumatic cylinders, and servos and steppers are used in various places, also in robots. Okay. Then comes the sensor. So this is a limit switch. Okay, so sensors are used to collect information about the internal state of the robot, or to communicate with the outside environment. Okay, so robots are often equipped with external sensory devices such as vision system, touch, and tactile sensors, which help to communicate with the environment. So let's say there's an object that I place on it. So this, what will happen is, this switch will go down, and NO will convert into NC. So NO is normally open, and NC is normally closed, which is used in the programming stage for the PLC. Okay, so when it becomes NC, so NC, the whole circuit is completed, and then a robot can function as to what it is programmed for. Okay. Then this is the controller in which this is a PLC in which programming is done, as to what kind of function has to be actuated and has to be performed, and it coordinates with the actuators as to when it is normally open, when it is normally closed, and this is how the controller works. Okay. So now let's go get on with the robotic configuration. So first is
Sir, hello.
yes, please.
Please tell me about controller again.
Okay, so we'll go to controller again. So controller is used to control all these actuating elements. So let's say this sensor, as I told you. Okay, so this sensor is going to convert. So I'll give you a normal example. So let's say this is an circuit. Okay, this is a lamp. This is globe. So what do we call this kind of circuit? Okay, in industrial automation, we are going to call this kind of circuit as normally open. Okay, NO, right? When this
Okay.
when this switch is completed, like when the switch is closed, we'll say this this electrical circuit is normally closed. Okay, so these are the elements that we use in the programming of the PLC. Okay, so controller is what it does is, so it gets some feedback from the sensor. As you know, we talked about it here, that it communicate with the outside environment. So let's say this is now normally open. So when the switch will come down to this place, it will become normally closed. So which is this one. Okay. So so how I'll tell you how we program the PLC. Okay. So this is this. Okay. So this circuit is the same as this one. Okay. I'll tell you how. So let's say this is a switch. Okay. This is a switch. It is now normally open. Okay, so it means that no current is flowing through it. When it becomes normally closed, like this one, okay, when it becomes normally closed, this is the lamp will glow. Okay, so this is the function that we program in the controller, and that is how some kind of task is performed. Okay, so I hope this answers your question.
Yes, sir.
Okay, good. So let's study the robotic configuration. Okay, so the first is the Cartesian robot. So these robots are made of 3 linear joints that are orient the and effector, which are usually followed by additional revolute joint. Okay, so this is the work envelope that I talked about. This is the work envelope in which this robot is going to move. So this it can move X, Y, Z axis. So as you know that we have 3 axes, X, Y, and Z. So this robot can move to this place, this. It can go up and down, and this can go left and right, right? So as you talked about that, this is the X reverse stroke. Then this is the vertical stroke up and down, and this is the left right stroke. Okay. Second is the cylindrical configuration. So cylindrical configuration robot have 2 prismatic joints and 1 revolute joint. So this this goes the same as the previous one, up and down, and this revolutes as it says here that it has 1 revolute joint. So because of this revolute joint, this work envelope goes like this. Okay, so it has some limit here, so that is why it cannot go 360-degree, and that is why it stops here. Okay. So this is the revolute joint, and this is the vertical stroke as it goes up and down, and then this is the horizontal stroke. Okay. Then the spherical joint, and so how it differs is. Any questions? No. Okay.
जो इतने cylindrical बोले,
Sorry.
hello.
Yes.
हाँ, cylindrical जो tell about, this is a hydraulic, non-hydraulic.
This is a sorry.
This is a hydraulic or non-hydraulic?
Okay, so see, when talking about a robot, the hydraulic and pneumatic thing depends on the application. So let's say that I have a payload for this robot. Let's say I have a payload for 10 kg. Okay, 10 kg.
Hmm.
Okay, and I want to
Okay.
pick a
Okay. Okay.
bottle. Okay, so I want to pick a bottle of let's say 500 gram or 1 kilo, 2 kilo, and up to 10 kg. So this robot can work on a pneumatic configuration. Okay, so let's say this goes beyond 50 kg or 100 kg. So then I'll have to use hydraulic system. Okay, so because it comes for a like a huge application. So I'll tell you about this hydraulic and pneumatic later, because we'll be covering this in the articulated slides. Okay,
Okay.
so
Okay.
the next, yeah, so the next is, sorry. Okay,
Tell. Tell.
yeah,
Tell.
sure.
Continue, sir.
So spherical joint. So they follow a spherical coordinate system which has one. Okay, so this goes the same as the cylindrical one. This covers the uh, the revolute uh, the revolute axis. Okay, so it covers like this, and then it has a vertical stroke also. So due to this configuration, it can go up and down, and it can reach like this. Okay. Then comes the articulated robot. Okay, so an articulated robot's joint are all revolute, similar to a human. So it can go like this, it can rotate like this, and the base can also move. And so I'll tell you one example of it. So let's say this end effector. Okay, so we want to do a spot welding. Okay, so spot welding, we can integrate a spot welding gun on this one, and that spot welding gun will go to some metal joint, and then it will go like this, and then it will make a spot and it will come back. So this kind of application requires heavy payload robots. So let's say 200 kg or 210 kg. So the default configuration of such robots is 210, which comes for different companies like Yaskawa, Kuka, and then Fanuc and everything. So for these kinds of robot, even these kinds of robot, we can integrate some kind of hydraulic system, and beyond below that we can use the pneumatic system. As someone asked this question, so this will answer your question as to for the different application for like this spot welding gun, which is weighing like 200, 190 kg or 180 kg. We can integrate these kind of system. Okay. Now comes the SCARA robot. So they have two revolute joints that are parallel and allow the robot to move in a horizontal plane, plus an additional prismatic joint that moves vertically. Okay, so this is the joint that goes up and down. So let me tell you what kind of application can be done with these kind of robots. So let's say the MCB is being designed for your mobile phone. Okay, so you need to have some very tiny. You need to pick and place very tiny pieces from one place to another. So these are the fast-moving robots which can work at a very quick pace in a small environment. And due to these revolute joints, it can compact itself, and let's say that it has a obstruction here. So this is the robot. Let's say this is the SCARA robot. So it has an obstruction there, so it cannot move like this. Okay. So what it can do is it can just be like this, and it can move here, and then it can open itself. Okay. So this is how SCARA robot work in the small environment, right? So now I have an exercise for you all. So this is a ABB robot, and this robot config. So what type of robot configuration does the ABB 140 robot have, and can you find out its workspace? Okay, so I would be needing some answers. Can you tell me like which kind of robot configuration is this? Am I audible, right?
I think
Yes, sir.
maybe all are new. You should
Okay,
start
yeah, yeah, sure.
explaining everything.
Okay, yeah, sure. Okay, so students, you don't have to worry. Like this is, I'm not taking your test. You can say anything. So we talked these configuration in the previous slide. So this kind of robot is a articulated robot. So it has these joints to perform some particular task. And as I told you that like the SCARA robot, I told you about the 210 kg payload. So 140, what 140 stands for is the payload of the robot. Okay, and then workspace can be workspace depends upon the different configuration of the robots as to what is the outreach and for the different things. And for this particular robot, the workspace is 1800 so it can go up to 1800 so it was not defined for you, but I'm telling you this. Okay, I mean, you don't have to shy around. Like we can make this a collaborative seminar. So I want your answers. Okay.
You mean to say that robotics are largely limited for the lifting of cages of 200 kgs and the movements of 1800 mm?
Now it depends on the application. So let's say that I'm making a car cell. Okay, so I'm manufacturing a Maruti Suzuki, let's say Swift. Okay, so there will be needing 4 robots of spot welding. Okay, so what those robots will do is that those robots will come and then it will spot weld those different elements of the robots, like the seat and then the gates and then the everything. Okay, so we have different applications for these things. So 1800, I'm just saying that 1800 reach is just an example. So 1800 is like 1.8 meters. Okay, so 1.8 meter is nothing for a car, and it has to the robot has to go way beyond that, because when you go into industries, so they will spend their money only one time, and they would want that it is being put to best use. So they wouldn't want to integrate 4 robots, and instead of that, they will only integrate 2 robots, which will move on this axis as to complete the whole spot welding process for the car. Okay, so different application calls for different kind of robots, and it doesn't always have to be like with large robots with 200 kg payload and everything. We can have 5 kg payload or 2 kg payload, as we talked about for the SCARA robots. Okay, so in that we just have to pick up chips of like 20 gram or 10 gram. So we can integrate very small robot for those for those applications. Okay. I hope this answers your question.
Yeah, yes. Continue.
Okay. So let's study some few different types of robot. So first is the mobile robot, which is this one. Okay, so these kind of robots that can move freely in the environment, and we can subdivide these into indoor robots, outdoor robots, terrain robots. So you guys have been working on Arduino. So Arduino is a like a microcontroller. So we can we can program it for different things, and we can make these kinds of robots for this one. And it can be outdoor, indoor, and for it can be, let's say you're going to a hill and you want to perform some particular task. So terrain robots can be integrated. Okay. Then there are robotics arms, which are stationary robots that have manipulators, that we talked about in the previous slide, that the articulated robots, which are used in the car manufacturing plants. Okay, so these are usually not considered AI because they do not perform planning and often have little to no sensory input. Okay, so these robots are pre-programmed by a human. Okay, using teach pendant. Okay, so without a teach pendant, those robots are like dumb metal pieces, and if they are not programmed, they cannot perform a task by itself. So let's say that I want to weld this piece from here to here. Okay, so if I don't program this thing, like I will have to program this from like the robot will come from this one, then it goes like this, then the welding will start, then it goes from here to here, then the welding will be switched off, and then it will come like this, and then it will go to the original place. So we have to program everything. it cannot even decide its own path. We have to decide the path for the robot. Okay, so we have to be the brain behind that robot, right? So the
Sir, what is the use?
yes.
Sir, what is the use of mobile robots?
Okay, so mobile robots can be used in the places, let's say that it can be used in the warfare environment, it can be used in space, it can be used in places, let's say that there's a place in the industrial area that is 100 degrees Celsius. Okay, so now the thing is that there is a conveyor belt and there is some unwanted piece on that conveyor belt that is obstructing the whole line. So either you can, just quickly go inside and pull out that piece, but that can cause some burn injuries. Okay. Instead of that, you can integrate this mobile robot and just make it go inside, and that particular kind of mobile robot can pick that object and can remove it from that place. So it doesn't have to be this small. This robot, it can be integrated with the arm, so which can pick and place these kind of robots. Okay, these are also used in places like the dumping grounds and all. Okay,
Yes, sir. Yes, sir.
right. Now come the autonomous vehicles, like mobile robots, but in this case they are combination of vehicle and computer controller. So autonomous cars, autonomous plane drones, autonomous helicopters, submarines, space probes. So autonomous cars, you must have heard about the Tesla. Okay, then the plane drones that US military is using, which is used to carry out drone strikes and all. Okay, so there are different classes of autonomous vehicle based on level of autonomy. Some are only semi-autonomous. So you guys have heard about the Mahindra XUV 500 that was just launched. Okay, so that is a example of semi-autonomous. I'll tell you how. Let's say this is a robot. This is a road. Okay, so this is a robot, and our car is. Just consider this a car. This this round object. So there is a feature in this Mahindra XUV 500 that if this car is about to move from its place. So let's say the person is asleep now and he goes like this, and the car starts moving like this, left. Okay, so it has a like those sensor which can keep it in within this space. Okay, and the robot and the car can move itself, and it will maintain the same speed throughout. And this is the kind of semi-autonomous that we are talking about. And the fully autonomous vehicle is this Tesla one that will like get you from one place to another without even the intervention of a human. Okay. So then comes the soft robots. So robots that use soft computing approaches. Example, fuzzy logic neural networks. So let's say, have you guys seen a caterpillar? So caterpillar is this small insect which goes like this. So what it does is to move from one place to another. First is it goes like this. It stretches itself like this, and then it moves from one place to another, going like this. Now this kind of motion can be performed from a soft robot. Okay, so this is still in the developmental stage, and like MITs and some big colleges are carrying out some researches on this. So what can be done is that like a muscle. So let's say this is a muscle, and I pull some pressure on it, and it goes like this. The same concept goes with this soft robots. So let's say that I can make this robot go from one place to another, and if I want to turn it, I will just pull this string, and it will go to the right side, and if this string, then it will go to the left side. Okay. Then come the mimicking robot that learn by mimicking. For instances, robots that learn facial gestures, or those that learn to touch or walk or play with children. So there is this, let's say for the example of Rajnikant. Okay, so the Chitti robot, that robot can mimic the person who is in front of it. Okay, so let's say I move my hand like this, so it will go also like this. Okay, If I turn my head like this, it will go like this. It will mimic what we are doing. Okay. Then the soft robots, soft bots, software agent that have some degree of freedom, or in some cases, software agent that can communicate over network, which is the same as the soft robots. And then the nanobots. Okay, theoretical at this point, but like mobile robots, they will wander in an environment to investigate or make changes. So it is still in the developmental stage. So I'll tell you this kind of robot. So this kind of nanobots are being manufactured by Tesla currently. So those are called as neural networks. Okay, so you can Google it out. So these are small chips like of this size that will be placed in our head, and we will be able to control the thoughts of a human. We will be able to see the thoughts of a human. We will be able to control a human by configuring his brains and these things. So these are nanobots that can be used in the places of a human body. So any questions so far? Okay.
I have a one question before I go out of this because I have one more engagement. What is which are all the field of all these things are being done, both the mechanical, computer, and electronics people together? Is it a interdisciplinary activities?
Yes, sir. I'll tell you about this. So it is somewhat related to mechatronics. Okay, so it is a interdisciplinary field. As you said that it is the integration of electrical, mechanical, computer. So these are the things that can be integrated. So I'll tell you this. So let's say this robot, articulated robot, will go behind. So this robot. So this has a mechanical configuration. Okay, okay, to it can be controlled without integration of a computer. If it is a hydraulic robot, it can be like we have few switches. So if we press this button, the right one, it will move to this side, then left button to move this side, then up and down. So these things. Integrating of electrical helped us in the integration of sensors. Okay, so this can so we cannot if as we talked about in the previous slides, that the word robota means a worker. So if we are going to control this robot, even though it is a worker, and we are not saving much money. Okay, so making this as intelligent robot, we are integrating few sensors in it as to make this an intelligent robot so it can sense its environment. Now, integration of computer helped in the programming of the robot so that it can work by itself. So integration of sensor with the help of those sensors, it can detect that there is a obstruction in front of it. And with that integration of computer, you can program it like, so if you get an obstruction, you can move to this place and go like this. Okay. So that is how it is a multidisciplinary field, and this can be, integrated for different applications.
One more question. For
Yeah.
this assembly of mobile phone things and all these robotics are being imported or it is made in India?
Okay, so India is adopting this, advancement. You won't believe that, people still ask that is robot is being integrated in our society. The robot has been in India since the 2005. Okay, so this kind of robot I have seen from the 2005. And firstly, it was not made in India. Like as company, we had different tax issues and different things. But as the company started coming in, they have, made their, manufacturing plants all over India, and we can find these ABB plants, KUKA plants, FANUC plants, and everything all over India. So it is also manufactured abroad as well as in India and as well as in many other countries.
Okay,
Hello.
thank you. Please
Hello,
continue.
sir.
Yes.
Hello.
Yes.
Hello, sir. Hello.
Yes. Yes, please.
Yes, sir, I am a professor in one engineering college. I am having a 20 years of experience in the teaching line.
Mhm. Sorry, you have a 20 years of
Nowadays,
experience in the teaching line.
yeah.
Okay.
See, nowadays everybody is concentrating on AI and data analytics and what is that? The data structure and all those things, artificial intelligence
Okay.
and AI.
Yes.
Everybody is shifting from mechanical stream to other branches.
Okay.
Say, suppose what is the future of robotics?
Okay.
Suppose,
Yes, yes.
see, your presentation is good, everything is good, but nowadays so many engineering colleges are which one closing down the mechanical. See,
You
what
are
is the
from which college, sir? You
Okay.
are from which college?
see, I don't want to mention the college.
Okay.
See,
Yeah.
because of COVID,
Mhm.
so many what is what is the admission strategies which one coming down,
Okay.
and because of there is no scope for mechanical engineers, and everybody is shifting to
No, I am.
Okay.
what is that?
Yeah, I am. I wanted to answer this, professor. I
Hmm,
am from. Actually, I was in Bosch for 35 years in R&D.
okay.
Without mechanical, without thing, no industry will run.
Yes, sir. Everything
Somehow this
see
has
nowadays.
gone into the minds of the students and particularly people like professors like you,
Hmm.
parents and the society has to put them. Without a mechanical, nothing is there.
See, everybody is shifting from.
Sir,
Yeah, that is where all
I'll,
of us
It is
should
also
take
the same thing.
a responsibility to make it.
yes,
In the
sir,
next couple of years, everywhere this scenery will change.
right, sir.
Universities are working. AICT and other people are also trying to work to change the mindset of such things from the students.
Sir, I'll tell
Because
you one thing.
software people are paying 30, 40,000, 50,000 to begin with, and engineers are not interested in going for mechanical.
Okay. So,
I
sir,
don't think such scenario will continue forever, Professor.
yes, sir. I'll tell you. I'll elaborate. I'll continue this as you told about. So, what? So the thing is that the mechanical and the robotics field is still unexplored by the students in the colleges. Okay, so let's see that you are going to learning a robot is not that easy, not that hard, and programming of PLC and everything you can just learn them within 2 to 3 months. Okay, but the thing is that making it intelligent, as you told about that AI, they are shifting to AI and everything. These AI and data analytics can be introduced in these robots, and people don't know about that. Okay, so I'll tell you how this can be implemented. So let's say this robot is equipped with a machine vision, okay, and AI, and there's some particular kind of softwares. So we can map these robots and we can visualize these robots, which is the ROS. Okay, so we can visualize on that software itself, and we can visualize the whole line as to what the task is going to be performed. So let's say that I have a stacking function. Okay, so there is this wardrobe. Okay, and I have to pick some random objects from this place, and I have to place it in this place. So what this robot, how AI can be implemented in this is that this robot can pick this object, and it will search with the help of machine vision. It will search for different kind of places that it can be equipped with. Okay, so let's say that it has some hole in the first rack, and then some hole in the second rack, and then some hole in the third rack. So it will, according to the size of that object, it will determine that which rack is the best for that object, and then it can be placed in that. So this is the unexplored field of the robotics. Now coming to the data analytics part. So let's say that some breakdown is occurring again and again on some kind of robot. So these robots are equipped with multiple sensors, and it can tell, like the car, like when it gets, when it's breakdown on the road, and you get a blinking light on the panel that there is some faulty thing with battery, or there's some faulty thing with your oil or anything like anything. So this is the same way that a robot is equipped with different kind of sensors. So collecting that data and integrating, let's say that I have my own industry and I have 50 robots in that industry. Okay, so I cannot go to individual robot for different kind of, for the breakdown that is occurring on different robots. So what I'll do is that I'll integrate some kind of program for the whole, that is, we can integrate a SCARA, that, some kind of fault is occurring again and again. So we can record that data, and according to that, the collected data, we can work on that specific thing, which will save us money, time, and our labor cost. So that is how AI and data analytics is being implemented into robotics, and not just robotics. It is being implemented into different fields like the IoT also, and then some also electricals and everything. So AI and ML is the next thing. AI and data analytics is the next thing, but it cannot work without the integration of these traditional things that is being taught in the college, like the mechanical or the electrical aspect that is being taught.
Hello, sir. One last
Yes.
question.
Yes.
See, we suppose if we are at the age of 50, suppose if you, where actually we will get the training at least for 15 days for robotics in Bangalore.
15 days of robotics in Bangalore.
Robotics training, do you have any robotics
Yeah,
online?
so we have a particular kind of course which is developed, and you can enroll into that, and our team can share you the details after these presentation. And we have integration with different labs. We can take you to those labs, and different teaching can be done for these robots, right?
Okay, sir. Okay, sir. Thank you, sir. Thank you very much,
Yeah.
sir.
So should I continue, or there are some other questions? Okay, so I'll continue then. So these are some few of these different kind of robots that is used. So this is the autonomous vehicle. Then this is the space rover. Then this is kind of an interesting robot, which is the Asimo. So as people say that when is the robot is going to be integrated. This robot, you won't believe that this robot was developed in the 2000s. It was developed by Honda, and this particular robot can be used to perform different kind of daily tasks. That it is this kind of robot is called a humanoid robot. So this robot can perform various tasks, like when you greet him with this handshake, it will greet you back. Then you can ask him to do different functions, like get me a cup of coffee or get me this thing. You can ask him different kind of questions as to for a student. Let's say that I have a 8-year-old daughter, and I want her to play with this robot. So if she has a question like, how big is the moon, or how far this moon is from my place, so it can answer these kinds of questions. So it is kind of a human, but in the form of a robot. Okay. So then this kind of robot is not at all artificial intelligence. It is just a mechanical robot that is being carried out with different kind of controllers or motors, and it is just making it can be used to make some gesture with the eyes, gesture with the face. It cannot speak, it cannot perform a task, but this is the kind of mechanical knowledge that we need for these kind of robots. Then these robots are used by the bomb squad, and to so this robot can go into critical places and can defuse a bomb or disarm a bomb. Okay, this is the articulated robot that we talked about. Then this is a robot that is being developed by Boston Dynamics, which is a company based in US. And this robot can be used to carry heavy payload, like in the warfare, as you can see in this picture, that it is carrying the weight of the bag, which are heavy bags for the soldiers that are in the warfare zone. Then this space rover can move by itself and can be controlled from Earth. And it is integrated with few sensors, and this is the solar panel, as you can see here, and it can be used for different terrains. So hence these kind of different wheels, right? Now let's see we were studying about the I was telling you constantly about the Chitti robot. Now, what do you think that this kind of robot was? If any one of you can answer, like which kind of robot do you think this robot was?
Humanoid.
Yes, that we talked about in the previous slide, like the Asimo. So this kind of robot that they say that this is it had a speed of 1 terabyte and a memory of 1 zettabyte. So actually, that thing is that it has a contradictory statement because the zettabyte memory takes up a lot of space. Okay, zettabyte. It is 10 raised to power 21 times of GB. Okay, so this kind of data can be stored in hard drives, but not within the size of his head. Okay, so that was one contradictory statement. Second was the law of robotics. So we studied about the law of robotics that in the first law, it says that a robot cannot harm a human, but this robot was taking over, killing people and taking over different things. So the second thing was that. Now the third thing, the mechanical and the computers part. Okay, so mechanical part. So it was integrated with different kind of actuators, and it was integrated with different kind of servos and steppers motor. Actually, servo motor because it has a feedback, and so that it can know itself that he's moving his arm like this or he is moving his head like this, and these things. Then comes the computers part that it was programmed in such a way. So it was actually driven by AI. Okay, AI as well as machine learning. Okay, so I'll tell you how it was integrated with AI and how it was integrated with machine learning. So AI was the thing that it could have performed a task by itself. Okay, so let's say that in the movie we saw that it was driving a car by itself. So he was driving that car according to his own pace, and he was learning to drive. And the then Rajnikant that asked him that just drive slow and drive according to me, and don't do anything without approving my instructions. So he crashed into a divider, and because he was not being given some instructions, so he was constantly learning, as well as he had some aspects of how to drive a car. So how to drive a car was AI, and the machine learning that he got feelings and everything that Rajnikant was teaching him. That was machine learning, that he was learning things from the surroundings. Okay, so that is how AI and ML is being introduced in the robots. Okay, so humanoid robots and the autonomous vehicles, and then the industrial robots, articulated robots, and so these everything nowadays is being integrated with AI ML. So let's say in the industrial robot, you know what a grinder is, right? You all know what a grinder is.
Yes, sir.
You all know, right? So you all know
Yes,
what a
sir.
grinder is. So let's
Yes,
say
sir.
articulated robot, in the end effector, some kind of grinder is attached with it. Okay. So let's say this is a metal piece, and I have to cut this metal piece into, I have to reduce the metal piece size by 100 mm. Okay. So what I'll do is that if a human is performing its task, it will grind some surface, then it will check again, then it will grind some surface again, then check again, and everything. Okay. But with the intervention of a robot, this task can be, let's say the human was performing this task in 1 hour. With the intervention of a robot, this task can be performed within 10 to 5 minutes. Because as the robot is grinding the surface, it is constantly assessing it with the help of machine vision. So let's say that this some kind of pressure is being applied, and then some kind of rotation speed is on the grinder, and it is rubbing this. So it can calculate itself, and it will know that in this amount of time, this surface will be 100 mm less. So that is how it is in AI and ML is implemented in the industry. Okay. Any questions so far? Okay, so let's move on. So this is the end of the slide, and thank you all for listening to this slide, and please let me know if there are any questions.
Hello, sir.
Yes, please.
Sir, what is the difference between robot and human being?
So a human being can work by itself. Okay, so let's say I have a brain. Okay, and even though I'm a human, I'm being constantly being taught by machine learning. So our brain, let's say we are 1 years old, then 2 years, 3 years, and then going on in our life. People say that with growing age, you gain some experiences, okay, and you learn from your experiences. So that is machine learning. That is also implemented in the machine. So we are some kind of a robot, but we can learn by itself. We don't need to be programmed. We don't need to be. We are not just a metal piece without being programmed. A robot has to be programmed by a human. Yes. Okay, so a robot has to be programmed by a human. It cannot program by itself. But in the coming ages, in the coming time, the machine learning will be able to program by itself. But there will always be those robots will always follow those three laws of robotics, that it cannot harm a human. It always has to obey a human, and it has to be human has to be there to to make a robot do some tasks, perform some tasks.
Thank you so much, sir.
Yes, Vinay.
Hello, hello, sir. Sir, is there any way after engineering, mechanical engineering, to join or to go in robotics, robotic
Sir,
engineering?
can you repeat again, please?
Sir, is there any way to go in robotics after mechanical engineering?
Yeah, I mean, you see, you never stop learning, and I mean, even if you are, as we had some teachers with a very experienced teacher with us, so they were 50 years of age. Okay, they can learn those robots within like a few days, and it is not that hard. It's just that you have a advantage of a mechanical background, so you won't have to put that so much effort into it as much as other people will put those efforts into it. So let's say the non-technical background people, and to learn these robotics, you can enroll with us, and we have some few courses that are being taught, and our team will get to you. If you want that, you can talk to them. Okay.
So, what are the job opportunities after robotics?
There are ample number of jobs for robots, but the thing is that what interests you will get you a job. Let's say that even though you let's say that I'll give you an example. So a few days back, I met a person. Okay, he did his electrical BTech, and for 5 years he was not getting a job. And I saw his resume, and that person did a project on Arduino. Okay, so I asked him that a particular reason that you did a project on Arduino or some computer programming course that he did. So he said that everybody was doing it, and so I did that as well. But you have to assess yourself as to what do you want to, what is your goal, and what do you want to become, as to what impresses you. Let's say that my field is robotics, and for a robotics, robotics impresses me, and I love working on robotics. So that is my field, and I've chose that field. But if you have a mechanical and you are just going into robotics just for the sake of it, that robotics is the future, that is not going to help you. Okay, you need to assess yourself first, and our team members can also help you with that thing, as to assess as to what interests you so much. Okay.
Okay, thank you, sir. Thank you so much.
Okay. I have some hand raised by Jitesh. Jitesh, is there any question?
Sir, can we do the practical sessions on robotic in colleges, sir?
Yeah, of course we can. See, integrating robots are large as well as small robots, but getting them wired and then getting them all ready, it can take up to 1 week. Okay, then we will have to move this lab from one place to another, and let's say you are from different place, then someone is from different place, and then like different places. Okay, so it can be done, but the thing is that there are different labs for it. So as ETG has tied up with many companies, and so you what ETG can help you is that they can take you to some different industries. They can help you in integrating of different kind of usability of and applications of robots. And yeah, I mean, yes, it can be done, but not in the college. But like the tied up college, we are setting up different labs in different colleges. Then surely in some time, but not currently. Okay.
Okay, so thank you, sir.
Then Uday Kumar, please. Do you have any questions?
This session is very interesting, sir. It's a nice presentation.
Yeah, thank you so
And
much.
regarding the students, if you implement, somebody told the practical session, it should be helpful for the youngsters. Because in our olden days, we did the mechanical engineering from Mysore University.
Right, right.
From 93 to 97, we didn't have in this type of facilities. And from 20 to 2000 onwards, the lot of improvement has been taken place.
Right.
If you enrich this knowledge to which one rural people, rural engineering colleges and backward people,
Right,
and
sir.
if you which one enrich the knowledge and what is the horizons and visions for the which
Sir, right, sir. I'll elaborate
for
this topic.
the generation.
Yes, sir. I'll elaborate this topic now.
And another thing is,
Yes, sir.
if you enrich this knowledge to the professors also,
Yes, sir.
they are having the both teaching as well as practical session. If you are well versed with these things, then they will guide the students for their projects, and
Right.
it helps a lot for the engineering colleges. And also they will get more opportunities in R&D field also.
Right, of course, sir. So what this, see, I'll tell you about our company. Elite Techno Group is, reducing that gap of, practical aspect and, theory aspect. So in colleges, the main focus is on the theoretical aspect of the learning, but mechanical aspect is being, left apart, and it is not focused. But we are integrating with colleges, and we are developing few things, and within within few days or few weeks, we'll be taking some session as to I'll be practically doing some things, and you will be if you're from abroad or you're from some different places of India, we'll all be learning this thing. And we have, sir, we will be integrating some different lectures and seminars for teachers as well. And for that, sir, we will surely inform you, and I'll update this thing for to my team also.
Thank you, sir. Thank you very much, sir.
Yes, yes. Are there any more questions, please? Let me know. Okay, so we'll wind up this session now, and it was a really interesting session with you all. And I hope you learned. Yes, Aurobind, please.
Thank you, sir.
Okay, sure. So I hope you all learned a few things of robotics as to how these all were implemented, and how the history came into being, and how the advancement is being done. So we will be taking some few seminars, in the coming weeks also, and I hope you all will study few topics as I told you in these slides, and we'll be doing some more interesting session, and then we'll be doing some exercises as well. And I hope you all will answer some, I hope you will speak more in the next coming lectures. And yes, and we'll be, sending you some course links as to if you want to integrate, if you want to learn these robotics deeply, we can help you with it all. And yes, so that is, we will wind up now. And thank you so much for attending this session.
Very, very. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Thank you, sir. होगा देखो
Thank you so very much.